Next is your rotational axis of symmetry. It is the line passing through the crystal along which if we rotate it through a particular degree, it will give you an indistinguishable structure. So based how many turns it will take to complete 360 degrees of rotation is your n-fold rotational axis. We have two-fold rotational axis, that is, it is being rotated by 180 degree, and we are getting in 2 times, if the crystal is rotated, we are getting the original structure. Similarly, three-fold rotational axis, in which it is being rotated by 120 degree. 3 बार घुमाया, we are getting the original structure. Next is four-fold, 4 बार घूमेगा, that is 90 degree. So this is the way we can go. Similarly, six-fold, that will be 60 degree. So you can see this here. If I go for the two-fold rotational axis of symmetry, it is being rotated by your 180 degrees, and it gives the similar appearance of the crystal. So you can see these many figures. One in the cube we are doing this. One from this point to this point, then from this to this, all your opposite phases. If it is the front of the upper portion, it is the back of the rear. It is the rear portion of the same crystal. So it is going from diagonally from top to bottom. Now you can see it is making these many. There are these many types of axes. So the total number of two-fold rotational axes is 6, because we have 6 figures in it. 1, 2, 3, 4, 5 and 6. But what is the order? How many turns it is making to return back to the original one? It is 2. Because in 2 complete rotation, we are getting 360 degrees back. Similarly, if I move to the three-fold axis, the degree I told you, it will be 120 degrees. So it will move how many times? 3 times. Order of rotational symmetry will be 3. But what are the axes? Now we are taking from that was the midpoint, but these are from the ends. From 2 opposite ends, 2 opposite corners. We have 4. So the total three-fold rotational axis of symmetry is 4. Now if we move on to the four-fold, angle becomes 90 degree. When angle becomes 90 degree, how many turns will it make? It will make 4 turns. So the order becomes 4. But how many structures? Structures are 3. Because what we are doing, we are taking it from opposite midpoint of the opposite sides to midpoint of the opposite sides. Moving over to the six-fold symmetry. It is generally in the hexagonal structure. It has to turn 6 times because the angle is 60 degrees. So order is 60. But how many total operations we can have? We will have 7 different rotational axes. So I hope this clears how many rotational axes a particular structure will have. Now what is the center of symmetry? This is possessed by all your crystalline substances, but it is only one. It is that midpoint in the crystal such that if we draw any imaginary line through that point, both the sides or both the lines from that point are equal. So it is only one per crystal. you cannot have more than one center of symmetry. Now next is, what are the elements of symmetry that are possessed in a simple cubic structure? We know a cube has all sides equal. So, plane of symmetry it will have 9. How many rotational axes will it have? 13. Center of symmetry, irrespective whatever it is, it will always be 1. These are the plane of symmetry which a cubic crystal is possessing. I told you there are 2 planes. One is the rectangular plane and the other is the diagonal plane. And you can very well see rectangular plane is 3, whereas diagonal plane is 6. So that makes it 3 plus 6, 9. And in the previous slide what we told you, that there are 9 plane of symmetry. But how many axes of symmetry we talked about? 13. We have 3. This order of rotational symmetry is 4. Then we have 4 of this with order of symmetry 3. So that makes 3 plus 4, 7. Then 6 with order of symmetry 2. So 6 plus 4 plus 3, that makes it 13. In this, what is the angle? It is 4. That means angle is 90. Then it is 120. And in the twofold, it is 180. So you can see there are 13 axes, rotational axes of symmetry. Next is the center of symmetry, which I told you it is the only one that is being possessed in the center of the crystal, in the heart of the crystal. That is always 1. So total element of symmetry in a cube, 9 plus 13, that makes it 22 plus 1, 23 elements of symmetry are present in a simple cube. So with this, I end my lecture of today. Thank you. We'll continue again in my next lecture.